Welcome everyone. I'm Majid and you're watching Lucid Mind. Today we'll solve paper 12 from March 2024. Let's start. Question 1. Which species contains the same number of neutrons as carbon 14-6 and same number of electrons as sodium 23-11 positive? Number of neutrons is mass number minus atomic number, so 14 minus 6 is 8 neutrons. For number of electrons, we have to look at the atomic number. Atomic number is 11, so there must be 11 protons. As we have positive charge, so 1 electron is lost. So 11 minus 1, 10 electrons. Fluorine, 17 minus 9, 8 neutrons. And we have 9 protons, it is neutral, so 9 electrons. Nitrogen 3 negative, 16 minus 7, 9 neutrons and 7 protons, 7 electrons plus 3 more, so we have 10 electrons. Neon 20 minus 10, 10 neutrons, and as it is neutral, so 10 electrons. Oxygen 16 minus 8, 8 neutrons, and 8 plus 2, 10 electrons. So correct answer is D. Question 2. Which process has largest enthalpy change per mole? Okay, we can see 1 electron is being lost by each of them. Let's see, we have aluminum 3 positive. Aluminum, the atomic number is 13. Electronic configuration is 2 electron in first shell, 8 in second shell, and 3 in third shell. As we have aluminum 3 positive, so 3 electrons are lost, 2 in first shell, 8 in second shell. Now it becomes aluminum 4 plus, which means that electron is removed from second shell. So now we have 7 electrons in the outermost shell. Let's do the same for others. So we have phosphorus. Phosphorus is 15, 2 in first shell, 8 in second shell, 5 in third shell. Phosphorus 5 positive, P 5 positive, 5 electrons are lost, so we only have 2 shells. And P 6 positive, electron is lost from second shell. Sulfur 16, so 286, as 6 positive, 6 electrons are lost. Sulfur 7 positive, electron is removed from this shell. So everything is similar. Then we have silicon 4 positive. Atomic number of silicon is 14. So 284. In 4 positive, again we have only 2 shells. And in silicon 5 positive, 1 electron is removed. So the electron is removed from same second shell. The only difference is on the positive charge. Now, greater the positive charge on cation, stronger will be the force of attraction between nucleus and electrons. So it means highest energy would be required to remove electron from sulfur 7 positive. This is because the charge is the greatest. So greater the positive charge, greater will be the enthalpy change per mole. Correct answer is C. Question 3. Which sodium compound contains 74.2% by mass of sodium? We have sodium carbonate. Sodium carbonate is Na2CO3. Let's find molecular mass. So there are 2 sodium, 23 into 2, plus carbon and 3 oxygen. So 12 plus 48. This is equal to 106. Now let's find out the percentage of sodium. Percentage can be found by using formula. Percentage of an element is equal to atomic mass of that element into number of atoms divided by mR of compound into 100. Okay. So atomic mass of sodium is 23, number of atoms is 2. So 23 into 2 over mR of compound 106 into 100. This gives us the percentage of sodium. So it's 43.4%. This is wrong. Then we have sodium chloride, NaCl, 23 plus 35.5. So mR is 58.5. Now using same formula, sodium is 23, total mR is 58.5 into 100. 39.3%. Incorrect. Then we have sodium hydroxide. So 23 plus 16 plus 1 is equal to 40. 23 atomic mass of sodium divided by total 40 into 100. This is equal to 57.5%. So incorrect. Then we have sodium oxide, Na2O. So 2 sodium, 23 into 2, 1 oxygen, 16. This is equal to 62. So 23 into 2 divided by 62 into 100. So this is 74.2%. So correct answer is D. Question 4. What is the maximum volume of sulfur dioxide gas measured at room conditions produced from burning 100 decimeter cube diesel fuel containing 0.8346 grams of sulfur? So this is mainly the combustion of sulfur to form sulfur dioxide. So we can write the equation S plus O2 forms SO2. Equation is balanced, so mole ratio is 1:1. We have mass of sulfur, so we can convert the mass into moles. Moles equals to mass in grams divided by atomic mass. Atomic mass of sulfur is 32.1. So number of moles present in 100 decimeter cube of diesel is 0.026 moles of sulfur. So if 1 mole of sulfur forms 1 mole of sulfur dioxide, then obviously 0.026 will form same moles of sulfur dioxide. So now we have this much moles of gas produced. As we have room conditions, we can convert these moles into volume. So volume equals to moles into 24 dm cube or 24,000 cm cube. So 0.026 into 24,000. Volume of sulfur dioxide gas is 624 cm cube. Correct answer is D. Question 5. Which row shows the correct number of covalent bonds in a molecule of methyl propane? We have to find the number of sigma bonds and number of pi bonds. Let's draw methyl propene. In propene, we have 3 carbons in long chain. 1, 2, 3. As it is propene, so double bond can be on this side or that side. Methyl propene means methyl is the substituent. Rest are the number of hydrogens. We have double bond. And hydrogen atoms. So every single bond is always a sigma bond. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sigma bonds, and there is just one pi bond. So correct answer is C. Question 6. Aluminum chloride exists as Al2Cl6 molecules at room temperature. When heated to high temperature, AlCl3 molecules are formed. What are the arrangements of bonding pairs of electrons around the aluminum atom in two forms of aluminum chloride? So we have to find out the shape. AlCl3 and Al2Cl6. So aluminum belongs to third group, so it has 3 electrons in outermost shell. It forms 3 single covalent bond with 3 chlorine atoms. No other electrons are present around the central atom. So these 3 are at maximum bond angle, which is 120 degrees, and all 3 are in the same plane. So this is planar molecule Al2Cl6. In Al2Cl6, we have 2 AlCl3 joined together. Okay, now this aluminum is electron deficient because it has 6 electrons in outermost shell. So 1 electron is provided by this chlorine atom. A coordinate covalent bond is formed. Similarly, this chlorine makes a coordinate covalent bond with that aluminum. So now octet is complete. So if we are looking at this one, now we can see there are 4 bond pairs around the central element. So when we have 4, it is tetrahedral structure, and bond angle should be 109.5. Correct answer is B. Question 7. The table shows the physical properties of 4 substances. Which substance has a giant covalent structure? For giant covalent structure, we have silicon dioxide in mind, SiO2, it is giant covalent. We have diamond in mind. This is also giant covalent structure. So electrical conductivity of aqueous solution. Silicon dioxide and diamond both are insoluble. Electrical conductivity of liquid, these two are bad conductors. Electrical conductivity of solid, still poor. Boiling point is very high because giant covalent structures. Melting point is also very high because of giant covalent structures. So correct option is D. Question 8. At room temperature and pressure, water is liquid, H2S is a gas. What is the reason for this difference of state? Now in water we have oxygen bonded to 2 hydrogen atoms. Oxygen is more electronegative, so it is partial negative. Hydrogen is partial positive. We also have lone pairs present on oxygen. So fluorine, oxygen and nitrogen, they form hydrogen bonds. So water molecule can form hydrogen bonds with other water molecule, while in H2S we have sulfur bonded to 2 hydrogen atoms. There is no hydrogen bonding, although it is also a polar molecule. So because of hydrogen bonding, water has high melting and boiling point. So that's why it is a liquid. Let's see the options. Oxygen has higher first and second ionization energies than sulfur. So the size of oxygen is smaller as compared to sulfur. This statement is true, but it has nothing to do with the state. The covalent bond between oxygen and hydrogen is stronger than the covalent bond between sulfur and hydrogen. Covalent bonds does not make a molecule liquid or gas. It is actually the intermolecular forces of attraction between the molecules. There is significant hydrogen bonding between water molecules but not between H2S molecules. This is correct because in water we have oxygen, which is one of the member of hydrogen bonding. The instantaneous dipole induced dipole forces between water molecules are stronger than the instantaneous dipole induced dipole forces between H2S molecules. Now these molecules are already polar, so we do not have instantaneous dipole induced dipole forces, we have permanent dipole forces. Correct answer is C. Question 9. The enthalpy change for a reaction can be calculated from values of enthalpy change of formation, enthalpy change of combustion, and bond energies. The enthalpy change of reaction given is delta HR, which expression could be used to calculate delta HR. So we have three options. We can use enthalpy changes of formation or enthalpy changes of combustion or bond energies. Let's start with bond energy values. We have C2H6. C2H6 is ethane. There are 2 moles. So in terms of bonds, we have 2 moles of C single bond C. So 2 into C single bond C. 1, 2, 3, 4, 5, 6 carbon hydrogen bonds. So 2 moles into 6 is 12 CH bonds. So this is the enthalpy change of the one of the reactants. We can see we have C single bond C only present in this one. There is no other molecule that has carbon single bond carbon. So the enthalpy change is not multiplied with 2. And we have carbon hydrogen bonds in CH4, in C2H6, it is only multiplied with 2. In product, we can see that we have CH4, and again there are 2 moles. So 4 carbon hydrogen bonds into 2 is 8, so it should be either 8 CH bonds or 12 CH bonds. They have written only 2, so in terms of bond energy, bond enthalpy, this is incorrect. Now let's do enthalpy changes of combustion values. So we can rewrite this equation. C2H6 O2 CH4 CO2 and H2O. We can write the combustion products. So whenever hydrocarbon is combusted, it forms CO2 and H2O. When methane is combusted, it forms the same product. We need oxygen. Okay, we have to find the enthalpy change of reaction for this one. So let's write down the moles from balanced equation. We have 2 moles, 3 moles, 2, 2, and 2. Let's balance it. So we have 4 carbons. We can write 4 CO2. We have 8 hydrogens, 12 hydrogens, and 12. 6 into 2. Balancing of oxygen is not necessary. So let's do this. We have C2H6, it combusts in oxygen. So this will be enthalpy change of combustion of C2H6. As there are 2 moles, so we can multiply this with 2. On this side, we have 2 moles of CH4, which form this product. So enthalpy change of combustion of CH4 into 2. Let's draw 1 step, 2 steps. So both tails emerge from this point. So this is the starting point. Both heads are here. So this is the end point. This will be direct step and this will be indirect step. So we have 2 delta HC C2H6 is equal to 2 steps in which we have delta HR and 2 moles of enthalpy change of combustion of CH4. Let's rearrange to form delta HR. It is equal to 2 delta HC C2H6 minus 2 delta HC CH4. So we have 2 moles of delta HC C2H6 gas minus 2 moles of delta HC CH4 gas. So this is the correct expression. We cannot use this one because this is only for C2H6. Then we have third method, which is for enthalpy changes of formation. Let's do the same for this equation. So first the equation, we have C2H6 oxygen, it forms CH4, carbon dioxide and water. Enthalpy change of formation means when something is formed from the elements in their standard states. So to make C2H6 we need carbon, we need hydrogen, we also need oxygen. This is delta HR. Alright, so 23222. So 4 carbons, 12 hydrogens, 6 oxygens. Now enthalpy change of formation means when number of moles of product is formed from the reactants, from the elements in their standard states. So we have 2 moles of C2H6, we can write 2 into enthalpy change of formation of C2H6. Similarly for this one we can write 2 into enthalpy change of formation of CH4, 2 into enthalpy change of formation of CO2, and 2 into enthalpy change of formation of water. We have one step and we have 2 steps. So let's make an equation out of this. So 2 into delta HF C2H6 gas plus delta HR, it is equal to these 3. So we can rearrange to form delta HR. Del HR is equal to 2 delta HF CH4, 2 del HF CO2, 2 del HF water, and this when gone over there will become negative. So 2 del HF C2H6. Let's see what have they given us. So del HF CH4 plus del HF CO2 plus del HF water minus this, but they haven't added the number of moles. So there are 2 moles of each, so that's why this is incorrect. Correct answer is therefore B. Question 10. Which reaction has an enthalpy change equal to the standard enthalpy change of formation of propane? For this you need to understand what is enthalpy change of formation. In enthalpy change of formation we have 1 mole of product, which in this case is propane, formed from the elements in standard states. So let's see what is propane. Propane is C3H8 They have given us 3 gases and 1 liquid. Now for alkanes, carbon 1 to carbon 4 is gas. So propane is gas, not liquid. Let's find it out. So we should have elements. On the other hand, we have carbon element, we have hydrogen, H2. In elemental form, hydrogen is written as H2. So this is incorrect. Now we can see we have 2 options. C, gas. In normal state, carbon is solid, it is not gas. Carbon should be solid, hydrogen should be H2 gas, C3H8 is also gas. Let's look at the balancing. So 1 mole of product is formed and equation is also balanced. 3 carbons are balanced, 8 hydrogens are balanced. So correct answer is C. Question 11. One of the reactions in rechargeable lead acid battery is shown. Lead solid, lead oxide solid, H plus aqueous, sulfate aqueous forms lead sulfate and water. Which statement about this reaction is correct? We have to find out lead is both oxidized and reduced. Lead is neither oxidized or reduced. Lead is oxidized, lead is reduced. So lead is Pb. Let's find out the oxidation states first. So Pb is 0 in element form. Then we have PbO2, 2 oxygen is -4, so Pb is +4 as it is neutral. In Pb sulfate, sulfate is -2, so lead must be +2. So let's see 0 to +2. This is oxidation. And +4 to +2. This is reduction. So lead is both oxidized and reduced. As we have 2 moles of lead sulfate, so 1 mole of lead is oxidized into lead sulfate, another mole of lead oxide forms another moles of lead sulfate, which is reduction. Correct answer is A. Question 12. KMnO4 is an oxidizing agent. Its reaction with iron 2 plus is shown in the following ionic equation. What are X and Y when equation is balanced? Let's see, we have MnO4 negative and we have Mn2 positive. We have iron 2 positive and iron 3 positive. Now let's look at the change. First, let's find out what is the oxidation state of Mn here. So we have 4 oxygens, 1 Mn and negative charge. Mn, 4 oxygen is -8, negative charge. So Mn -8 equals to -1. Mn is equal to +8 -1, which is +7. So it goes from +7 to +2. The change is 5. From iron +2 to iron +3, the change is just 1. So the changes should be balanced. We can balance them by using any number of our choice. In this case, we can multiply this by 5 so that the change is balanced. So we have 5 moles of iron 2 plus and 5 moles of iron 3 plus. MnO4 does not need to be multiplied with anything else because 5 and 5 is now balanced. So X is 1. This is also 1. Iron will be 5 and 5. To balance H positive, we need to find out the total charge. So we have -1 charge on MnO4 negative. Iron is 2 plus, there are 5 moles, so there is +10 charge. H plus is unknown. On the product side, we have +2 charge. There are 5 moles of iron 3 plus, so it is +15, and water is neutral. So in total, we have +17 on the product side. +10 -1 becomes +9. So we need to make this +17 to make them equal. In order to make them 17, we have to add 8. So we can add 8 moles of H plus. Now charges is balanced, so hydrogen needs to be balanced, so we have 4 moles of H2O. Now oxygen is also balanced, so we had to find the values of X and Y only. X is 1, Y is 5. Correct answer is C. Question 13. Nitrogen and hydrogen are mixed in a reaction vessel. The reaction reaches equilibrium, giving a mixture of nitrogen, hydrogen, and ammonia gases. This is equilibrium. The mixture of gases present at equilibrium at a total pressure of 300 atmosphere is shown. We have gas and we have number of moles in the mixture. What is the equilibrium constant Kp for the forward reaction? Kp is partial pressure of product, which is ammonia, as this is forward reaction. Raised to the power is number of moles, which is 2, given in the equation. Then we have partial pressure of nitrogen raised to the power 1 and partial pressure of hydrogen raised to the power 3. Now partial pressure can be found by using this equation. Partial pressure is equal to mole fraction into total pressure. We can start with ammonia. So partial pressure of ammonia, it is equal to mole fraction into total pressure. What is mole fraction? It is the number of moles of ammonia divided by total number of moles. So moles of ammonia is 160. Total moles is 160 plus 590 plus 180. Total pressure is 300 atmosphere. Alright, so for partial pressure of ammonia, we have 51.61 atmosphere. Let's do the same for other two. We have hydrogen, we have nitrogen. So partial pressure of hydrogen, moles of hydrogen 590 divided by total moles 180, 590, 160. Into total pressure 300. So partial pressure of hydrogen is 190.32 atm. Then we have nitrogen. So same thing, partial pressure of nitrogen is equal to moles of nitrogen 180 over total moles. So partial pressure of nitrogen is equal to 58.06 atmosphere. Now we have partial pressure of all of them. We just have to put values in this part. So Kp is equal to partial pressure of ammonia 51.61 squared over nitrogen 58.06 atmosphere into 190.32 cube. So Kp, it comes equal to 6.654 exponential minus 6. We have 2 and we have 4. So atm power 2, atm power 4. The resulting atm is atm minus 2. Correct answer is therefore A. Question 14. A mixture of hydrogen gas, iodine gas is placed in a reaction vessel of volume V at temperature T. Hydrogen plus iodine reacts to form hydrogen iodide at equilibrium. All substances remain in gaseous state. Argon gas is then pumped into the reaction vessel. The temperature is maintained at T. How are the rate of forward reaction and partial pressure of HI at equilibrium affected? Let's see. Argon gas is unreactive. So it neither helps forward reaction nor helps backward reaction. So it means it does not affect equilibrium position. And we can see that temperature is maintained at T, so temperature does not change. When temperature does not change, Kc does not change. So rate of forward reaction is unaffected because it is not a part of the reactant molecules. Then we have partial pressure of hydrogen iodide at equilibrium. Partial pressure of hydrogen iodide is also unaffected. Now we can change partial pressure of hydrogen iodide if moles of gas is changed, in this case moles remain same, or volume of container changes, volume of container does not change in this case, or if temperature is changed. So these three things can affect the partial pressure of hydrogen iodide at equilibrium. Correct answer is therefore D. Question number 15. Two experiments are carried out to study the reaction between zinc and sulfuric acid. In experiment 1, small lumps of zinc are added to excess sulfuric acid. In experiment 2, the reaction is carried out at a lower temperature and with one other change. Both experiments produce the same total volume of gas and are completely in the same time. What is the second change made in experiment 2? So we have zinc that reacts with excess sulfuric acid to form zinc sulfate and hydrogen gas. So in first experiment we have excess dilute sulfuric acid, so it means that zinc is the limiting reagent. So volume of gas, it depends on the amount of zinc used. In first experiment, small lumps of zinc are added to excess dilute sulfuric acid. So it is not powdered, it is lumps, so we'll have less surface area. In second experiment, the reaction is carried out at lower temperature. So lower temperature decreases the speed. So we have to compensate the speed by using one another change because both experiments carry out at same time. So what is the second change? A catalyst is added. Catalyst speeds up the reaction. This could be true. A greater mass of zinc is added. Now zinc is the limiting reagent, so if amount of zinc is increased, volume of hydrogen also increases. But it says it produces same volume, so we cannot increase mass of zinc. A greater volume of sulfuric acid is added. It does not affect the reaction because it is already in excess. We have larger lumps of zinc are used. Larger lumps means even more decreased surface area. So it cannot speed up the chemical reaction. Correct answer is A. Question 16. The relative magnitude of the property X of 5 elements is shown. P, Q, R, S and T are all in period 3 and have consecutive atomic numbers. The letters are not the actual symbols. We have P, Q, R, S, T. Which row is correct for property X, which is along y-axis, and element R? So element R has the highest. First thing is electrical conductivity. So in period 3, we have metals which are good conductors. So we have sodium, magnesium and aluminum. These three are metals. So from sodium to magnesium, conductivity increases because delocalized electrons increase. From magnesium to aluminum, electrical conductivity increases because aluminum has 3 electrons in conduction shell. So from sodium to magnesium and magnesium to aluminum. So R could be aluminum. Second thing is electronegativity. Now across period from left to right, size decreases, nuclear attraction increases because number of protons increase. So electronegativity also increases. So electronegativity values should still keep increasing after R. It cannot be electronegativity because it is decreasing from R to next elements. Next is melting point. Melting point depends on the types of bonding and also the intermolecular forces of attraction. So we have metals, sodium, magnesium, aluminum. Melting point increases as we move across. Then we have silicon. Silicon has the highest melting point. This is because silicon has giant covalent bonding. So it cannot be aluminum because after aluminum, silicon has the highest. Electronegativity is not maximum for silicon. It should be for chlorine, which is group 7 element. Then we have second ionization energy values. Now ionization energy also depends on the size of element. So as we move across the period, size decreases, atomic number increases, nuclear attraction increases, electronegativity increases, so ionization energy value should also increase. So after silicon we have phosphorus, then sulfur, then chlorine. Chlorine is the most electronegative, so ionization energy value should keep increasing. It should not decrease from R to S. So most probable answer is electrical conductivity, and it is maximum for aluminum. Question 17. Element X is in period 3. Element X reacts with oxygen to produce a solid Y. When solid Y is added to water, a solution with a pH of less than 7 is produced. What is the identity of element X? Sodium Na reacts with oxygen to form solid sodium oxide. This sodium oxide is basic in nature because it forms sodium hydroxide when dissolved in water. So pH is not less than 7, it is more than 7. A is incorrect. Then B is silicon. Silicon reacts with oxygen to form silicon dioxide, SiO2. SiO2 is insoluble in water. So there is no pH change. Phosphorus reacts with oxygen to form solid phosphorus oxide. This is non-metal oxide, so it can react with water to form acidic solution. We have H3PO4 aqueous. So the pH can be less than 7. Then we have sulfur. For sulfur, it reacts with oxygen to form sulfur dioxide or sulfur trioxide gas. so it does not produce a solid Y. Correct answer is C. Question 18. This question refers to isolated gaseous species. The species F minus, neon, and sodium positive are isoelectronic. This means they have same number of electrons. In which order do their radii increases? So we have F negative, fluorine's atomic number is 9, so there are 10 electrons. We have neon, atomic number is 10, so there are 10 electrons. We have Na positive, atomic number is 11, so there is one less electron as compared to protons. We have 10 electrons, they are isoelectronic. Now radius, it depends on the nuclear attraction. So cation always has the smallest radius as compared to anion. Anion always has the largest radius. So in between them, it is neutral. When you have same number of electrons, you can use this reference that cation is always the smallest and anion is the largest. So smallest should be Na positive and largest should be F negative. Neon is neutral, so it should be in the center. Correct answer is C. Question 19. Separate samples of magnesium and calcium are added to an excess of dilute sulfuric acid. The observations are summarized in the table. For magnesium, the reaction is vigorous, bubbles of gas is produced, magnesium completely dissolves. For calcium, vigorous reaction initially, bubbles of gas is produced, then reaction soon stops and leaves most of the calcium unreacted. Which statement explains the difference in these observations? So first part A, we have calcium is better oxidizing agent than magnesium, or calcium is better reducing agent than magnesium. Now magnesium and calcium, they are present in group 2. As we move downwards from magnesium to calcium, loss of electron increases. So we can say reactivity increases. As metals, they lose electrons, so reducing strength also increases. So calcium is a powerful reducing agent as compared to magnesium. Calcium is not better oxidizing agent, calcium is a better reducing agent. So then why the reaction stops? It does not explain the stopping of reaction. Let's move further. It says that magnesium is more reactive metal with all dilute acids than calcium. This is incorrect because calcium is more reactive than magnesium. Magnesium sulfate is more soluble than calcium sulfate. This is true because for group 2 sulfates, if we move down the group, solubility of sulfate decreases. When calcium sulfate is formed, it is not insoluble, so sulfate layer is present around calcium. Because of that, calcium remains unreacted. So D is the correct answer. Question 20. Dolomite is a double carbonate, CaMgCO3 twice, and can be used instead of calcium carbonate for treating acidic soils. The three statements all refer to the agricultural use of these carbonates. Number 1. Dolomite and calcium carbonate are both less soluble than calcium hydroxide. Now carbonates of group 2, they are always less soluble than hydroxides of group 2 because carbonates are insoluble in water. So for group 2 carbonates, the solubility is less. While group 2 hydroxides, they are comparatively soluble. As we move down the group, the solubility of hydroxide increases. Part 2. 1 mole of dolomite has the same neutralizing effect as 1 mole of calcium carbonate. In dolomite, we have calcium carbonate, we also have magnesium carbonate. So there is a double carbonate. So if we compare it with 1 mole of calcium carbonate, so obviously there will be more neutralizing effect of this carbonate as compared to 1 mole. So this is incorrect. Dolomite and calcium carbonate both increase the pH of acidic soils. Carbonates, they can react with acid to form salt water and release CO2. So acid is neutralized into water. Third option seems correct because acidic soils, they can be neutralized by adding carbonate. So 1 and 3 are correct. Correct answer is therefore B. Question 21. This question is about two salts, sodium iodide and sodium chloride. The two solid salts are separately added to warm concentrated H2SO4 and results are noted. Aqueous solutions of the two salts are separately added to silver nitrate and then concentrated ammonia is added and results noted. So which row is correct? First we have salt, then identify one product formed with concentrated sulfuric acid, and then observation after silver nitrate and ammonia aqueous are added. Let's do the reaction with concentrated H2SO4 of sodium chloride and sodium iodide. NaCl, it can react with concentrated sulfuric acid to form NaHSO4 and release HCl. This HCl does not further react with H2SO4, so HCl is not one of the product. Second part is sodium iodide. Sodium iodide can react with sulfuric acid in several steps to form different products. Among those products we have NaHSO4, hydrogen iodide, iodine, sulfur dioxide, sulfur and H2S. So sodium chloride does not produce chlorine, does not produce H2SO4. Sodium iodide can form H2S and it can also form I2. Now let's see what happens when silver nitrate and ammonia aqueous are added. Now we have aqueous salts. So in aqueous sodium chloride we have Cl minus, in aqueous sodium iodide we have I minus. It can react with silver nitrate. In silver nitrate aqueous we have Ag positive. So it will form precipitates AgCl and AgI. AgCl is white in color while AgI is pale yellow. Further, if we add aqueous ammonia, concentrated aqueous ammonia, so AgCl, this precipitate, it dissolves while AgI does not dissolve. So it means for Cl negative we have colorless solution, not a white precipitate. For iodide we have yellow solution because it remains insoluble. Correct answer is therefore C. Question 22. The diagram shows the process of adding calcium nitrate and strontium nitrate to a separate boiling tubes and heating them. Identical conditions are used. If calcium nitrate it is heated, then gases formed a bubble through water which contains universal indicator. Same thing is for strontium nitrate. As the reactions proceed, the water containing universal indicator changes color. Which row describes the color change and identifies the nitrate that causes the quickest color change? So color change is green to blue, and we have, let's see which one is quickest. So in universal indicator, green color, it represents neutral solution. As water was neutral before, so it was green. Then blue, it means basic solution. And we have red color means acidic solution. So let's see group 2 nitrate, we have calcium nitrate and strontium nitrate. We can use metal M instead of nitrates. So nitrate decomposes to form metal oxide, nitrogen dioxide and oxygen gas. This nitrogen dioxide is brown and acidic gas. So it will decrease the pH of water. So universal indicator will turn from green to red because the solution becomes acidic. Now let's see which one is faster, calcium nitrate or strontium nitrate. Calcium nitrate is above in group 2 as compared to strontium nitrate. Strontium is below in group 2. So as we move downwards, the thermal stability increases. This is because size of cation increases and polarizing power of cation decreases. So it is more easier to decompose calcium nitrate. This one will be faster. Correct answer is therefore C. Question 23. The equations for 3 reactions involving chlorine or its compounds is listed. We have KClO3, we have KClO3, we have KOH plus Cl2. Which statement about these equations is correct? Part A, equation 1 describes the formation of compound used to kill bacteria in drinking water. Now bacteria can be killed in drinking water by using HClO, perchloric acid. This is not present in equation 1, so incorrect. B, equation 1 does not represent a redox reaction. Let's see, redox means reduction as well as oxidation. K is +1, Cl is -1, oxygen is 0 as it is molecular. In this part, single oxygen is -2. Let's find this chlorine. So KClO3, overall no charge. Potassium is +1, then we have chlorine, 3 oxygen is -6. So chlorine -5 equals to 0 or chlorine equals to +5. Let's see if there is any change. So potassium does not change. Chlorine goes from +5 to -1, which is reduction. Oxygen goes from -2 to 0. This is oxidation. So equation 1 does represent a redox reaction. Part C, equation 2 describes the formation of potassium chlorate 4. Let's see if this is potassium chlorate 4. We can find that by finding out the oxidation state of chlorine. So KClO4. Overall neutral. 1 potassium, 1 chlorine, 4 oxygens. Chlorine -7 or chlorine equals to +7. So it is potassium chlorate 7, not 4, because chlorine has oxidation state of +7. Equation 2 and 3 both represent disproportionation reactions. Now disproportionation means self-oxidation reduction. So in KClO3 we already know chlorine is +5. In KCl it is -1. So +5 to +7 is oxidation, +5 to -1 is reduction. So yes, this is a disproportionation reaction. And equation 3. So let's look at equation 3. We have molecular chlorine, so 0. KCl it is -1. In KClO3 it is +5. So 0 to -1 is reduction, 0 to +5 is oxidation. So both equation 2 and 3 represent disproportionation reaction. Question 24. Nitrogen monoxide is a primary pollutant produced by petrol engines and is found in their exhaust gases. Which reaction occurs in a catalytic converter and decreases the emission of nitrogen monoxide? So in catalytic converters, we know that nitrogen monoxide and carbon monoxide, they can both react together to form nitrogen gas and CO2 gas. So let's balance. Nitrogen is 2. And we can balance oxygen as there is odd number 2 and 1 3 oxygens and even number on this side, so we can make both even. Alright, so nitrogen monoxide and carbon monoxide, it form nitrogen dioxide. This is incorrect, this is also wrong. Carbon dioxide is not one of the reactant. This is true statement. CO2 is not one of the reactants. So correct answer is C. Question 25. The diagram shows the structure of the naturally occurring molecule cholesterol. Student X stated that 17 carbon atoms in the 4 rings all lie in the same plane. Student Y stated that this molecule displays cis-trans isomerism at C double bond C. Which students are correct? Okay, let's see. We have 4 rings, 1, 2, 3, 4. We can pick out any one carbon and let's look at that. For example, this one, it is making 4 single bonds as it has 2 hydrogen atoms. So this carbon is sp3, so tetrahedral. Similarly, this carbon is bonded to a hydrogen atom and 3 other single bonds, so it is also tetrahedral sp3. This carbon is also making the same 4 covalent bonds, so tetrahedral and sp3. sp3 carbons or tetrahedral are not in the same plane, so student X is wrong. Student Y states that this molecule displays cis-trans at C double bond C. So these 2 carbons are making a double bond. We can see we have this carbon and this carbon. As this double bond is present in ring, so the ring structure does not show cis-trans isomerism. This is because of ring strain. So second student is also wrong. So which students are correct? Neither. The drug cortisone has the formula shown. In addition to those chiral centers marked by an asterisk, this one, and this one, how many other chiral centers are present in cortisone molecules? For chiral center, there must be chiral carbon. So if carbon is making a double bond, it is not chiral. If carbon is attached to 2 hydrogen atoms, it is not chiral. So let's see which one is other than these. Now this carbon is bonded to 2 hydrogen, so not chiral, not chiral. This is making a double bond, so not chiral, making a double bond, not chiral, not chiral. 2 hydrogens, not chiral, 2 hydrogens, not chiral, making a double bond, not chiral, 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, so and making a double bond. So these red carbons are not chiral. Let's look at the other ones. So we have this one. It is attached to 4 different groups, CH3. This side and this side and this side are different, so this is chiral carbon. And we have this one attached to CH3, left, right, bottom, different, so this is also chiral carbon. Let's look at this one. So we have OH, left, right, bottom, different, so this is also chiral. So we have 3 more. Correct answer is D. Question 27. But2ene reacts with cold dilute acidified KMnO4 to give product X. But2-ene reacts with hot concentrated acidified KMnO4 to give product Y. Which statement about product X and Y is correct? Okay, let's first draw the product. So but2-ene means we have 4 carbons. There is double bond between second and third carbon. Cold dilute acidified KMnO4. So it converts alkene to diol. Second is with hot concentrated acidified KMnO4, which breaks the double bond. So after bond cleavage, the carbon that is bonded to a hydrogen and alkyl group converts to carboxylic acid. So we have 2 carbon carboxylic acid on this side. This side is also similar, so another carboxylic acid. So we have 2 moles of 2 carbon carboxylic acids. So we have product X and we have product Y. Both product X and Y will react with 2,4-D and pH. Now 2,4-D and pH, it gives positive results with only aldehyde and ketone. This one is an alcohol, this one is carboxylic acid, so A is wrong. Neither product X nor product Y will react with 2,4-D and pH. This is correct. Product X will react with 2,4-D and pH, product Y will not. Wrong. Product Y will react with 2,4-D and pH. No. So correct answer is B. Question 28. A sequence of reactions take place. The major product is compound Z. We have propanoic acid, which is reduced to compound X, then dehydrated to compound Y, and then water is added to compound Z. Let's see what is compound Z. So we can do the reaction. Propanoic acid is 3 carbon carboxylic acid, CH3, CH2, C double bond O, OH. LiAlH4 is powerful reducing agent, so it can reduce propanoic acid into primary alcohol. So 3 carbon alcohol, CH3, CH2, CH2, OH. Then we have concentrated H2SO4, it causes dehydration. In dehydration, OH is removed from one carbon, H is removed from adjacent carbon, and alkene is formed. So CH3, CH, double bond CH2 plus water. So this is compound Y. Then we have vapors with steam. So we have water. Now hydrogen will attach to one double bonded carbon, OH to another double bonded carbon. But these carbons are different. One has 2 hydrogens, one has single hydrogen. So 2 types of product is possible. We have a major product and a minor product. In major product, according to Markovnikov rule, hydrogen attaches itself to carbon having more hydrogen atoms. So we have CH3, CH, OH will be attached to other carbon, CH3 instead of CH2. This is major product. In minor product, it is other way around. Hydrogen goes to carbon with less hydrogens. So CH3, CH2, and this becomes attached to OH. Okay, so it is asking about the major product. What is this? We have 3 carbon atoms. OH is present on second carbon. So propane 2-ol. Correct answer is D. Question 29, which statement is correct? Part A, bromoethane reacts with sodium hydroxide aqueous to form ethene as a major product. Let's do the reaction. Bromoethane means we have two carbons and bromine is also attached. We have sodium hydroxide aqueous. Now nucleophilic substitution reaction takes place in which OH replaces Br. So product is CH3CH2OH. It is not ethene, it is alcohol. So this is incorrect. Part B, 1-chlorobutane reacts more rapidly than 1-bromobutane with NaOH at the same temperature. So we have chlorine and we have bromine. Chlorine is more electronegative, smaller in size, so it has strong bond. Bromine is larger in size, less electronegative, so it has comparatively less strong bond. To break carbon-chlorine bond, 346 kilojoules per mole is needed. To break CBr bond, 290 kilojoules per mole is needed. So less energy means faster reaction. So 1-bromobutane should react more rapidly. This is incorrect. Part C. Hydrolysis of C2H5-3CBr occurs mostly by SN2 mechanism. Let's see which one is this. So we have CBr. 3 C2H5s are attached. So if you look at this carbon, it is attached to 3 other carbon atoms, so it is tertiary halogenoalkane. Tertiary halogenoalkane, it always follows SN1 mechanism. So again, incorrect. Last part, the CH3CH2CH2CH2 positive ion is less stable than this ion. Okay, let's see, we have CH3, CH2, CH2, CH2 positive. And we have CH3 positive. Okay, now we have positive carbon, which is electron deficient. This deficiency can be reduced by positive inductive effect of alkyl groups. These alkyl groups, they are electron donating in nature, so they have positive inductive effect. So we have positive inductive effect from 3 sides, and in this one, this carbon is directly attached to just one carbon, so positive inductive effect is just from one side. So this is more reduced as compared to this one. This one is more stable. So this will be less stable. Correct answer is therefore D. Question 30. In the hydrolysis of bromoethane by aqueous sodium hydroxide, what is the nature of attacking group and of leaving group? Let's do the reaction. We have bromoethane. Ethane means we have two carbons. Bromo means we have one bromine attached. This is bromoethane. Aqueous sodium hydroxide, it produces OH negative ions. This OH negative, it attacks partial positive carbon as it is attached to more electronegative element. So bromine becomes partial negative and these electrons go to bromine. So now what happens? CH2 gets attached to OH and Br takes away electrons. and the bond breaks. So OH negative is the attacking group. It attacks on partial positive side, so it is nucleophile, which means nucleus loving. Br negative also has negative charge and lone pair, so it is also a nucleophile. So both are nucleophiles. Correct answer is D. Question 31. X is an organic compound containing the elements carbon, hydrogen, and oxygen only. The table shows the observations made from 3 chemical tests carried out on X. When sodium is added, effervescence is seen. When sodium carbonate is added, effervescence is seen. When oxidizing agent is added, it remains orange. What is the possible structure of X? Let's see what is given. We have alcohol, carboxylic acid, aldehyde, secondary alcohol, aldehyde, tertiary alcohol, carboxylic acid, and tertiary alcohol. Alright, so sodium. Sodium can react with alcohol. Sodium can also react with carboxylic acid. So metal plus alcohol forms hydrogen, and alkoxide, metal plus acid, also forms hydrogen. So effervescence is seen. These two will react with sodium. Aldehyde does not react. Secondary alcohol does react. Aldehyde does not react. Tertiary alcohol can react. Carboxylic acid and alcohol can react. So B and C are wrong. It could be A or D. Let's look at second option. We have sodium carbonate. Sodium carbonate can react with acid because acid plus carbonate gives salt, water, and releases CO2 gas. So this CO2 gas is effervescence. So let's see which one has COOH. This one has COOH. This one has COOH. Third part is oxidation. So it says that on oxidizing agent it remains orange. So it means it cannot oxidize further. So in A we have secondary alcohol. Secondary alcohol, it can be oxidized to form ketone. Product will be this. Carboxylic acid cannot be further oxidized. It says remains orange, which means it should not oxidize. So A is incorrect. In D we have carboxylic acid, which does not oxidize. We have tertiary alcohol, which also does not get oxidized. So correct answer is D. Question 32. How many moles of oxygen gas are needed for complete combustion of 1 mole of this alcohol? Plus oxygen, it will form CO2 and H2O. Let's balance. 4 carbons are there, so 4 CO2. 10 hydrogens are there, so 5 H2O. Now oxygens, we have 8 in CO2 and 5 in H2O. So 8 and 5 is 13 oxygens. We have 1 oxygen in tertiary alcohol and we need 12 more. So we can make it 6. 6 into 2 is 12. 12 and 1 become 13. So correct answer is A. Question 33. In which pair will each compound give a different visible result with alkaline aqueous iodine? First one is CH3, CH2, OH. and CH3 C double bond OH. So as we can see, CH3 is present, which is directly bonded to carbon having OH, and CH3 is present, which is directly bonded to carbon having double bond OH. So both will give positive result with alkaline aqueous iodine. Second part, CH3CHO, it is this one, it gives positive result. Then CH3COCH3. So CH3 C double bond O CH3. Again we can see that CH3 is directly attached to C double bond O, so it will give positive result. Then we have CH3 C double bond OOH. Carboxylic acid, it does not give positive result with alkaline aqueous iodine. And we have this one. Let's see what is this. Looks like a ketone. So we have CH3 CH2 C double bond O CH2 CH3. So we have ethyl group. No methyl group is directly bonded, so it will not give positive result. Last one, we have 2 carbon alcohol, which gives positive result. We have C2H5CHO. C2H5 means we have CH3 CH2 and then it is aldehyde. So CH3 is not directly attached to C double bond O. We have ethyl group, it will not give positive result. So both are same, both are same, both are same, both are different. In D, both are different. So D is the correct answer. Question 34. Which reagent gives positive result with propanone? Propanone is a ketone, 3 carbon ketone, CH3 C double bond O CH3. First one is alkaline aqueous iodine. So we have CH3 directly attached to C double bond O. So yes, it will give a positive result with alkaline aqueous iodine. We have aqueous bromine. Aqueous bromine, it does not react with ketone. It gives positive result with alkenes. Tollens and Valence reagent, they give positive result with aldehyde, not ketone. Correct answer is therefore A. Question 35. Esters can be hydrolyzed with an aqueous alkali or aqueous acid to form 2 products. The table compares the 2 methods. Which row is correct? Let's see what is ester. So let's suppose we have R, C double bond O, O and R. This is ester and we have ester functional group. Now it can be hydrolyzed by aqueous acid. C double bond O part becomes carboxylic acid. This part becomes alcohol. We can also do hydrolysis by aqueous alkali. The carboxylic acid part changes to sodium salt. And other side is still alcohol. Alright, so let's see, with aqueous alkali we have complete conversion to a salt and organic acid. We have a salt and alcohol. Forms an equilibrium mixture with salt and organic acid. Again we have alcohol. Complete conversion to a salt and an alcohol. This is true statement. Now let's look at the aqueous acid. So forms an equilibrium mixture with an organic acid and an alcohol. So we have organic acid, we also have alcohol. This is true. Complete conversion to a salt? No. Forms an equilibrium with organic acid and alcohol? Yes. Complete conversion to organic acid and an alcohol. In acid hydrolysis, we have equilibrium reaction, while in alkaline hydrolysis, we have a complete conversion. So this one is incorrect. Correct answer is therefore C. Question 36. Structural isomerism only should be considered when answering this question. How many compounds with the molecular formula C5H11Br are primary halogenoalkanes? Now, primary halogenoalkane is the one in which halogen is attached to carbon, and this carbon is directly attached to only one carbon. So we cannot change these three. Rest we have 5 in total, so 3 more. So we have 5 carbons in long chain. It is pentane. Bromine is present on first carbon. So 1 bromo pentane. Let's draw the other possible structures. These 3 cannot be changed. Now instead of 3 we can make a branch. So 1, 2, 3, 4. There are 4 carbon atoms in long chain. On third carbon we have methyl group. So we have 1 bromo, 3 methyl butane. Next one, again bromine with CH2 and carbon. Let's take this substituent from this carbon to this carbon. Still this bromine is attached to one carbon, which is directly attached to one carbon. So the name will be 1 bromo 2 methyl butane. Let's do another one. Let's make 2 substituents here. So 1 bromo, and on 2 we have 2 methyl groups, so 2 dimethyl. We have propane. So in total we have 4. Correct answer is A. Question 37. Compound Z is formed by the reaction scheme shown. CH3CH2Br, it is formed with KCN in ethanol to form X, which reflux with dilute HCl forms compound Z. What is the formula of compound Z? So let's start with this one. We have CH3, CH2 and Br. So in the presence of KCN in ethanol, cyanide replaces bromine in nucleophilic substitution reaction. So we have CH3, CH2, Cn. This cyanide can be refluxed with dilute HCl to form carboxylic acid and ammonium salt. We used HCl, so it is ammonium chloride. So compound Z is propanoic acid. We have 3 carbon carboxylic acid. Correct answer is D. Question 38. Hydroxyethanol, we have OHCH2CHO, is heated under reflux with an excess of acidified potassium dichromate. This is oxidizing agent until no further oxidation takes place. What is the skeletal formula of the organic product? So let's start with this one. We have 2 carbons, CH2 and CHO, which is C double bond OH. So we have alcohol on one side and we have aldehyde on the other side. So when this is oxidized, primary alcohol converts to aldehyde and further into carboxylic acid. Aldehyde also converts into carboxylic acid. So we have carboxylic acid on both carbons. This is because of oxidation. So 2 carbon carboxylic acid is formed. In A we have 3 carbons, so it is wrong. In B we have 2 carbons and carboxylic acids, so this is correct. In C we have 2 carbons, one side is still alcohol, so incorrect. In D we have aldehyde on one side, which is also wrong. So correct answer is B. The formula shows the repeat unit of an addition polymer. This is addition polymer. CH3 is the substituent, CH2CH3 is also the substituent. What is the correct name of the monomer from which this polymer is made? Let's make this polymer first. So we have CH with CH3. We have another CH with CH2CH3. This is the repeat unit of polymer. When polymer is formed from monomer, pi bond is broken, so monomer formation would be the reverse. These electrons will come back to make a double bond. So monomer would be like this. We have double bond. Substituents are the same. One hydrogen with one carbon, one hydrogen with other carbon. Now in long chain we have 1, 2, 3, 4, 5 carbons. So we have pent for 5 and this is alkene. So pent and alkene is on second carbon, so 2-ene. Correct answer is C. Question 40. The infrared spectrum of a compound is shown. We have transmittance, we have wave number. Table is also given. Which functional group could the compound contain? Okay, so we have alcohol. Alcohol is OH functional group. Let's see. So OH and hydroxy, it should give a broad peak between 3200 to 3600. 3200 to 3600. There is no such peak, so it is not alcohol. Carboxylic acid is C double bond O OH. So there is carbonyl peak and there is OH peak. So OH peak for carboxylic acid should be this one. It is a broad peak between 2500 to 3000. 2500 to 3000. There is no broad peak, so it is not carboxylic acid. Then we have ester. Ester contains C double bond O. This is the functional group. So we have carbonyl and we have C single bond O. Carbonyl because of ester, it should be between 1710 to 1750. 1710 to 1750. We do have a peak over here. So second peak is C single bond O in ester. It is between 1040 to 1300. So 1040 to 1300. We do have a peak. So ester is present. Then we have nitrile. In nitrile, carbon makes triple bond with nitrogen. This nitrile should give a peak between 2200 to 2250. There is no such peak in this region. So nitrile is wrong. Correct answer is ester. Thanks for watching. If this was useful, please do like, subscribe, and share.